Hello, and welcome to Lesson 8, Session 3. And we're going to talk about, here's our objective again. We're going to talk about finding the slope of a line, okay? Finding the slope of the line and how we can do that in many different ways. We're going to run through this problem really quickly so we can get to the next page. Ashwani's family is getting ready for the local Holi festival. Ashwani mixes yellow and red food coloring to make an orange according to the graph. What is the slope of the line? And what does the slope represent? Okay, so we can do that. Now, a couple things to remember. You can pick any 2 points on this line to help you. Now, what I'm looking for when I pick these 2 points is points that perfectly hit the grid line, okay? So like this wouldn't be a very good point to pick right here because I don't really know what its y value is, okay? Like I'm going to be kind of guessing what it is, but if I pick this point right here, like I know exactly what its x value is and exactly what its y value is, okay? So it doesn't matter which 2 points you pick along here. You can use any 2 points. Now, if I'm thinking rise over run, how is my y changing divided by how is my x changing? I definitely want to pick 2 dots that are as close together as possible. So can I use this point and this point? Sure I can. Can I use this point and this point? Sure. Can I use any 2 pairs of points along this line? The answer is yes. But if you pick 2 points that are closer together, you're probably not going to have to simplify your fraction at the end, okay? So let's see what this is. What 2 points do you want to use? Let's use these for the heck of it. I probably would have used this one and this one, but let's use these for the heck of it. It looks like we're going from 4 to 8. That looks like a vertical change of 4. And it looks like we're going over from 10 to 20, from 10 to 20. So it looks like this is going to be a change of 10. So my slope is always how much I go up by how much I go over, okay? Or we could also say that this is a change in my y divided by a change in my x. Regardless, we're going to say that this is 4 over 10, which simplifies to 2/5. 2/5. And if we want to, we could even simplify this even further. 4/10, we could write this as 0.4, but either way, we can either say that our slope is 2/5 or 0.4. I typically say leave it as a fraction, but sometimes when we have a word problem, it's helpful to put it in decimal form. But either way, we're going to say we have 2/5. So we could say 2 ounces. What are we talking about? My change in my y. 2 ounces of red per ounces of yellow. And maybe this is when it's easier to write this in decimal form. We need 0.4 ounces of red food coloring per 1 ounce of yellow food coloring. And maybe you're asking, Mr. Gibbs, where'd you get that 1 from? Where'd you get that 1? Well, whenever we divide our fraction here, what's going to happen is we're going to end up making a unit rate. A unit rate. You learned that in 6th grade. A unit rate. That means we are going to compare some quantity to 1 of that other quantity. For instance, here we're comparing 2 of this quantity to 5 of this quantity. But when we divided this, we ended up with a unit rate. And that gives me how much per 1 ounce of something else. But either way, on this graph, it tells us we need 4 ounces per 10 ounces of this, 2 ounces of red per 5 ounces of yellow. If you take any 2 points, if I'm going to put in 12 ounces of red, I'm going to need 30 ounces of yellow, right? This slope helps us figure out how much coloring I need compared to how much of the other color I put in. On the next page, I want you to notice some even more important things, though. So we've been using this idea of a vertical change divided by a horizontal change. We've called that rise over run. Here's the next part, and I kind of introduced this to you real briefly, but I want you to see this, okay? This says you can choose any 2 points on the line and use the slope formula to find the slope of a line. You need to memorize the slope formula because you are going to use it so much over the next 2 years in this class and in algebra. You have to know it, okay? So for any 2 points that I pick up off of this line, so we found a whole bunch of different points here, right? I could have picked any 2 points, this one, this one, this one, this one, this one, this one, any 2 points, and used my slope formula, okay? Any 2 points, we always call them an x and a y, an x and a y. It's always in alphabetical order. I list an x value and a y value. And then here's my other point, another x value and another y value. The slope between these 2 points can be found using the formula. M, this represents slope. Let's write that down. M represents slope. M represents slope. Okay, so M, my slope, equals y2 minus y1 divided by x2 minus x1. In this formula, the letter represents slope. Oh, there it is. The letter M represents slope. And let's consider 2 points from our graph. So we talked about these a second ago, 10, 4, and 28. Now, this is what I always do. So if you do this, you probably won't mess it up. But somebody's going to be lazy, and then they're going to mess it up. As we're first learning this, I always put this key underneath these points. So I call it x1, y1, x2, y2. And when you do that, all you need to do then is pick up your numbers and plug them into the equation. So they picked up 8, put it here. Picked up 4, put it here. Pick up 20, put it here. Pick up 10, put it here. Well, 8 minus 4, what does that equal? That equals 4 divided by 20 minus 10. Oh, isn't that 10? Doesn't that equal 2/5 if I divide both of these by 2? Isn't that exactly what we did with our rise over run? And here's just a different way of doing it. And this is really important if I just give you 2 points. If I just give you 2 sets of value, no graph, no table, this slope formula becomes really, really important. So this is probably the most important thing that we have in this lesson here. So really make sure you understand that. So let's go on. I'm going to skip a page, and we're just going to go on to some application problems here. So, Oren is a wheelchair athlete competing in the 100-meter race. His coach tracks his progress in the table below. The coach plans to make a graph using these points. What will the slope of the line be? What does the slope represent? Show your work. What is the slope of the line, and what does that represent? Well, I'm going to tell you that if I've got a 0.0, this is going to be really, really easy, because this is changing 31.25 divided by a change in 5. I'm going to pretend that they didn't give me this. They didn't give me this, and we're going to make it a little more difficult on ourselves. But anyway, they gave me a point. They gave me a point, okay? So I can use my slope formula. Let's call these something. I'm going to call this y2 and y1. I'm going to call this x2 and x1, okay? Notice that x1 and y1 go together. x2 and y2 go together. Now I can use my slope formula. y2 minus y1 divided by x2 minus x1. Well, what is my y2? I labeled it. It's 62.5. And then I'm going to say subtracted by, what is y1? I'm just putting y1 right here, 31.25. And then x2, well, that's 10, minus x1, that's 5. Ooh, this is, what is this, 62.5 divided by, or minus 31.25? Well, that's 31.25 divided by 10 minus 5 is 5. Isn't that what we talked about first? And we knew that it was going to happen because this is a proportional relationship. He started at 0, 0 seconds for 0 miles or meters here. So what does this mean? He's going 31.25 miles every 5, or meters per every 5 seconds. I wonder how fast he's going for every 1 second. So I can take 3.25, or 31.25, divided by my 5, and I get this, which if I convert that into a decimal is 6.25. And we're going to say meters per second, per 1 second, right? So he's traveling 6.25 meters per 1 second. And whenever we do this division right here, we always get that unit rate. And that is really helpful to know exactly how fast he's going per second. Okay, let's do another one. The graph shows a relationship between cups of yogurt and cups of berries in this smoothie recipe. What is the slope of the line? Okay, let's do it. Well, if they're going to give me a graph, I'm going to use rise over run. Okay? And I pick 2 points that are close together. I'm just going to pick these first 2. Looks like I'm going up 1 and over 2. The slope of the line, rise over run, equals up 1 over 2. Okay? What does it represent? We could say that this is 1/2 cups of yogurt per 1 cup of berries. So 1/2 cup of yogurt per 1 cup of berries. Okay. Well, that's helpful to know. Instead of thinking, 1 cup of yogurt for 2 cups of berries, but that's the same as what we just wrote, right? Or 2 cups of yogurt per 4 cups of berries. Doesn't matter. She wants to use 9 cups of yogurt She wants to use 9 cups of yogurt. How many cups of berries should she do? Well, if I've got this 1/2 and I want to make this a 9 on top, well, 1 times 9 is 9. I'm going to need to do 2 times 9 gives me 18. Is 9 divided by 18 1/2? It sure is. We're going to need 18 cups of berries. Okay. Again, the graph shows how fast Heidi ran on the track. Heidi says she was running 1.5 laps per minute because 3 divided by 2, 3/2 is 1.5. What mistake did she make? How fast did she run? I'm guessing she did her horizontal change divided by her vertical change, her change in X divided by a change in Y, because that is the mistake that people make all the time. This is like 1.5, so I don't want to use that one. I want to use this one. We're going up 2 and over 3. The slope, thinking rise over run again, how much do I go up divided by how much do I go over, is 2/3. Ooh, which is like going to be, if I put that into a calculator, that's going to be an irrational number. That's going to be 0.6666 repeating, okay? So what mistake did she make? And let's say 2/3 of a lap per minute. She did run over rise. Don't do that. That's bad, okay? She did run over rise. You've got to go, you've got to do your vertical change divided by your horizontal change. That's the biggest thing people do. They do it here too. You put your X's on top and your Y's on bottom because the X's come first. No, the Y's have got to go on top. The X's have got to go on bottom. Okay, thanks everyone. Let me know if you have any questions and you should know what to work on next.